All right, here we go. 8.2. We're going to start talking about heat calculations. But what we do first is we're going to talk about phase change diagrams. And this is something you should have seen in Earth Science. It looks like this. So here we have a heating curve. And down here on the x-axis, this is the x right here, right? So this is the x-axis. We have the amount of heat that's being added. We'll talk about how heat is measured in a few minutes. And on the y-axis going this way, we have temperature. Okay, so we have it right here. And we have this line right here. Anytime the temperature is rising, you're adding heat and temperature is rising, this is a solid. And then the temperature levels off, and what that's illustrating is a solid becoming a liquid, and then the heat increases the temperature again, and that's when it is all liquid, and then it levels off again, and that's a liquid going to a gas, and then it goes up again, and you have all gas. Okay, a couple things we should know about this. Let's write it over here. We're going to talk about something called average kinetic energy. Average kinetic energy is just another way of saying temperature. Kinetic means movement. And so we are really measuring the movement of the particles as we increase our temperature. So kinetic energy changes on these slopes. The temperature is changing on those slopes. See how the temperature went from, let's say, -40 to 0 degrees? The temperature changed, so the average kinetic energy changed, or the kinetic energy changed. Here, the average kinetic energy remained the same. You can't see where I'm pointing, but it's right there. Okay, right there where my little cursor is. I think I can make it a pointer. Right there. The average kinetic energy is not changing, so the kinetic energy is staying the same. Here we have the kinetic energy changing again. Here we have the average kinetic energy remaining the same. And here we have the average kinetic energy increasing again. So wherever we have one single phase, solid, liquid, or gas, our average kinetic energy, our temperature, is changing. Now we have these flat parts. I like to call them the plateaus because it starts with the letter P. And on the plateau, okay, I don't know if I spelled that right, but on the plateau, you have a phase change. That little triangle means change. So we have a plateau, phase change. The kinetic energy is not changing because kinetic energy means temperature, but the potential energy is changing. Okay, so the way I always tell my students to remember this is P, P, P. Potential energy, plateau, phase change. P, P, P. So on the plateau, there's two of them. You've got a phase change, solid turning into a liquid or liquid turning to a gas, and you have potential energy that's changing. Obviously, if we're adding heat, the potential energy is increasing. If we're taking heat out, the potential energy is decreasing. Just want to make sure everybody understands that if we're taking a solid and we're changing it to a liquid, that is called melting. But there is another word for that, and we're going to see that in this unit. It's called fusion. Okay, fusion. So fusion is just a big fancy word for melting. And if you have liquid that's going to a gas, that is called vaporizing. And you're going to see vaporization in this unit as well. You can also have a liquid going to a, let's write this down here, liquid going to a solid, and that's freezing. And you can have a gas going to a liquid, which is condensing. That's mighty sloppy there. So you'll see that, let's say if we have the phase change diagram going in the opposite direction, the gas is going to be up here, the solid's going to be down here. So we have a gas, then we have a gas going to a liquid, then we have all liquid, then we have a liquid going to a solid. So this gas going to a liquid is, let's get a highlighter right here. Okay, that's gas going to a liquid. And then we have, I don't like that green, liquid going to a solid. That's happening right there. So this section right here is the freezing point, because that's where it is freezing. Freezing point. This is the condensing point, because we are taking heat out. See how the graph is going down instead of going up? Okay, where in the other one, let's go to another page so I can write. The other one, the heat was being added, and you can see that the gas was up here, the solid was down there. So where's the freezing point? The freezing point is right there. It's the same as the melting point. Solid going to a liquid, we're melting. Okay, so this is the freezing point or the melting point. This up here is the vaporization point or the condensing point. Okay, vaporization means you're going to go from a liquid to a gas. Alright, I don't know why I attempt to draw things when I can just go on the internet and find this awesome picture. So look at this picture that I just found. It's phase change diagram. It is a heating curve. I know it's a heating curve because heat is being added. You see the heat energy that's going in down here on the bottom. Let's label it. At point A, it is a solid. When I'm going from left to right, so that's this arrow right here, I am going to be going from a solid to a liquid. If I'm going from a solid to a liquid, I am melting. Okay, then I'll get to that box in a second. I'll get to this box right here in a second. But look at this one right here. Now I'm a liquid starting here. I'm going to start heating up again. My temperature is going to go up, and I'm going to be a liquid only. And then I'm going to go from here to here, and I'm going to be a liquid turning into a gas. If I'm a liquid turning into a gas, I'm vaporizing. And then this up here would be a gas only. And they gave you these awesome particle diagrams. Now, if we were looking at this graph and we're starting at this little green point up here, but we are reading this direction, you're still a gas there, but now in D, see how the arrow is going from right to left? We are a gas going into a liquid, okay? That is called condensing. And then C is obviously a liquid. And here we have a liquid going to a solid, which is called freezing. And then A, we would have a solid again. Where would the freezing point of this be? Right here. Where would the melting point be? Right here on this line. It's the same spot. Whatever this temperature is the freezing point and the melting point. Whatever this temperature is, there's no numbers here, it's going to be a condensing or vaporizing point. Okay? All right, that's for phase change diagrams.